This is number 20 on the UT. Had a lot of texts and emails from students about this problem. They were confused about this. Not exactly sure why. Let's talk a little bit about that. I'm going to go ahead and clone this to the other side, so we'll talk about what we can do. Okay, a problem like this, all you have to do, a problem like this is no different than just adding the vectors like we've always done. I can just grab this vector, grab this vector, grab this vector, grab this vector, and all I'm trying to do is determine what the magnitude would be from here to there. Now let's move everything back into place. Alright, so these two vectors are coming 55 degrees off the horizontal. And would have hoped you would have caught that anyway because it's a parallelogram. So all we have to do is add these together mathematically like we've done every other vector mathematically. There's nothing unique about this. So we're going to do that real quick. Alright, so instead of sum up the forces, we're going to sum up the distance this time. So sum up the distances in the x. We'll get 44 plus 44 plus 44 cosine 55 plus 44 cosine 55. Alright, I'll work that in just a second. Let's do the y's. Sum up dy. Oops. Make that into a dy. These two have no dy, these two have no y components, so we don't have to worry about this. So this time, instead of doing each of them separately, why don't we just put a 2 in front? 44 sine of 55. So that's all there is to it. Let's get our calculator. So I got 44 times the cosine of 55 times 2 plus 88. That gives me 138.47. We'll do these. That gives me 72.09. So now all we have to do is draw our vectors. I have one coming, oops, let me grab a vector, sorry. I have one coming 138.47 along the horizontal. I have one coming up at 72.09. We're looking for this hypotenuse. So go ahead and label this 72.09, 138.47. The resultant has got to be the square root of both of those. After I square them, put the 7 down here too. Alright, let's run those real quick. 72.09 squared plus 138.47 squared. Take the square root of that. It gives me 156.11. That's all you had to do, I believe, and I believe it was problem 20 on the UT assignment. And I hope that clarifies everything. But again, keep things simple. Vectors can be moved anywhere, as long as you can. The only things you cannot do, you cannot change direction, and you cannot change magnitude. All right, best of luck.